Okay, this is an introduction to the use of the CIM with Symbology and Pro. My name is Charlie McLeod. So here's our session focus. We'll be looking at the general structure of CIM symbol internals. Major focus of that is symbol layers, their types, their ordering with regards to Z order, some of the different combinations you can use, and then Hatchfields. We'll be looking at geometric effects and also another section on markers and marker placements, as well as kind of a specialty topic there, using a marker for text. Now, when I made the original recording of this session, it was just too long. There was just too much material. So I did have to cut a few things out. I had a demo on the Hatchfields example. I've left the code in the sample. So if you download the code for this session, I still left the code in that shows you how to do a hatch fill, but I had to take it out of the actual video. And then I also had a description in the slides of style project item, symbol style item, and then using them to retrieve symbols from StyleX files in Pro. So those slides are still in the PowerPoint, but me running through them, I've cut from the final video. Will be a number of examples, and the examples will be taken from point, line, polygon, and text. I'm not going to cover mesh or procedural symbols in this session. Okay, so really our first topic, the general structure. So symbols in the CIM are constructed by combining one or more symbol layers. And you can think of the symbol layers as being the display primitives that are used to render the symbols. Consist mainly of strokes, fills, and markers, but there are others. And they're the primary building blocks. The interesting thing about symbol layers is that they can be used in almost any combination. So there's really no limits to the mix of different symbol layers that you can use in a symbol. Now, point, line, and polygon symbols, they each derive from something called CIM multilayer symbol, and they contain their individual CIM symbol layers in a symbol layers property. Text is just a little bit different. It does not contain the symbol layers directly. Instead, it has a polygon symbol within its internal structure that it uses for rendering the text, that text.symbol property. When it comes to constructing symbols or symbol layers, a symbol factory is going to be a primary mechanism. There are a variety of ready-to-go off-the-shelf symbols that you can construct through, construct point, line, polygon, and text symbol overloads. And in those cases, they come with a set of predefined symbol layers. Or if you want to roll your own, you can use the construct marker, stroke, and fill variants, those overloads, to make your own symbol layers and then assemble them into your own particular combinations. So the symbol layers then are stored in CIM multilayer symbols in the symbol layers array property. And they're actually stored in that array in the reverse order to their display. So the layers at the end, they draw first and they'll be on the bottom of the symbol. The layers at the front of the array, well, they draw last, so they will be on the top of the symbol. Okay, so by way of illustration then, let's say we use a symbol factory to construct a couple of different symbol layers, a black stroke and a red solid fill. I instantiate a new polygon symbol, and I am storing into its symbol layers property an array of symbol layers that includes my stroke and fill. The last symbol layer in the array, the fill, it draws first, so it's on the bottom. The first symbol layer in the array, it draws last, so it's on top. Now, if I swizzle the order, well, now the stroke will draw first. It'll be on the bottom. The fill, it'll draw last. It'll be on the top. and so the fill will obscure the stroke. Same is true for lines. Here I'm constructing two strokes, a thin red line, 1.5, solid stroke, red, and a thicker black line, solid stroke, 3 points. I add the thicker stroke to the end of the array. I put the thinner stroke at the beginning. The thicker black line draws on the bottom, and then the thinner red line is rendered on top, kind of giving us that nice casement effect there. If I swizzle the order, now the thicker line is on top, the thinner line on the bottom. Well, then the thicker line is going to draw last, obscuring the underlying thinner red line. Now, there are no restrictions on which CIM symbol layers can be added to a symbol layers array. Yes, in the most common use cases, we see markers are added to point symbols. Of course, strokes get added to line symbols. And strokes and fills are added to polygon symbols. But there are no restrictions that say it has to be that way. Any of the symbol layers can be used interchangeably with any of the CIM symbols. Whether the combinations make sense or not, well, of course, that's a completely different story, right? But there are no technical restrictions. You can mix and match the various symbol layers in any combination you want. And I'll be showing you different examples of that throughout the session. So when we talk about the general structure, another aspect to be aware of is that CIM symbols and symbol layers contain what I've termed nested symbols. So that means that within their internal structure, they actually contain individual symbol properties. For example, text symbols and character markers, they contain an internal polygon symbol that they use to render the glyphs. Point and text symbols, they contain a polygon symbol to be used to render a halo. Vector marker symbol layers, deep in their internals, they have a polygon symbol that they use to render the markers. You can also replace the polygon symbol with a text symbol if you want to use the vector marker to display text. I'll be showing you an example of that, and so on. So the point is that whenever you come across one of these nested symbols, as I've called them, then any symbol satisfying the type of that particular symbol, point, line, polygon, whatever it is, any symbol can be used. No restrictions. It doesn't really matter on the context. Of course, whether the end result is effective or makes sense or not, that's a completely different story. But any polygon symbol can be assigned to any polygon symbol property, ditto for point, line, and text. So by way of illustration, here's a text symbol, just using the default font. I think it's Arial. I'm setting it to be 80 points. I'm constructing a polygon symbol. I'm going to use the same stroke and fill that I showed on the previous slides. So black outline, red fill. I reassign that polygon symbol to the text. So I replace whatever its current polygon symbol is with the one I just made. And the resulting text shows the black outline and red fill. Here's an example using a point symbol. So I just take the default point symbol. This happens to be a circle marker. I'm setting its size to 40 point. Once again, my polygon symbol, black outline, red fill. Now I have to really drill into the internals to get to the underlying polygon symbol. It's buried all the way inside the vector markers marker graphics. I'll be talking more about the internal structures of markers later. But the point is, it doesn't really matter where that polygon symbol is. I have a polygon symbol, I assign it. And so my point is now rendered with the same black outline and red fill. All right, so within Pro, the examples for this session, they create a tab called CIM Symbols. I'll discuss this doc pane shortly. On the tab, there are a number of buttons, the main ones being these guys right here. Place point, line, polygon, and text tools. and each one of these places a graphic. The graphic is symbolized with whatever is the symbol selected from this combo, and the entries in this combo correspond to the examples that we see in the session. So for example, example 1, example 2, and so on and so forth. Anyway, it should be pretty obvious. You set your breakpoint in the code. I'll show you where. And the whole point really is for you to set breakpoints in the debugger so you can see how the symbols are implemented kind of on your path, if you will, to learning how to do the manipulation of symbology yourself. Okay, so with that said, let's go into our example 1. I've got example 1 selected in the combo, and the first example we saw for example 1 was a polygon. So let's go ahead and place a polygon. Just going to digitize a polygon. There we go. Okay, so within the module1.cs file, there are actually 6 examples, example 1 through 6. And which example you've picked, of course, corresponds to the selection you made in the combo. And it'll bring you into the appropriate block in get symbol, for example. So if you simply set your breakpoints within the if statements for the particular example or examples that you want to debug, that's probably the way to go. We're on example 1 that I've called symbol layer order. And our demo symbol type currently is it's polygon. So we're going to symbolize a polygon, and we're going to use the same symbol that I showed on the slide, that 2-layer polygon symbol. Got a little flag as to whether to switch the layer order or not. I'll show you how that works in a second. Let's step in. And so here is our first example. We're going to make a black solid stroke with a symbol factory thickness 2, a solid fill, color red. And then I'm going to construct a polygon symbol with that stroke and fill. All right, if my flag is true, which it currently is, this stroke on top, well then guess what? I put the stroke first in index 0, I put the fill second in index 1. So here is my collection of symbol layers, just as I showed on the slide. Okay, so we've now constructed a polygon symbol with the stroke and fill. And there is our polygon symbol. For example 1, you can just check this reverse order, and that will swizzle the layer order. Now let's go ahead and do a second polygon. And you can see that now there is a very thin black outline, but for the most part, the outline that was 2 has now mostly been obscured by the fill, with the fill drawing second. Okay, let's take a look at the line. So now we'll do a line geometry. Okay, so now let's go to the lines. So here we go, symbol type line. I'm going to do example 1 symbol layer order line. Okay, same as on the slide. I'm going to make a 5-point black stroke, a 3-point red stroke, and depending on my flag here, in this case, I am doing the thick line draws first. So on the bottom, that's going to be my, oops, guess I need to instantiate them. That's going to be my stroke. That's the black thick line. Stroke 2, that's the thinner red line. And I get that nice casement effect. And of course, if I do the reverse order, digitize my line once again. And the red line is now completely obscured by the thicker black line. All right, so the second thing I showed in, I guess what I'm calling example 1, was swizzling out what I called a nested symbol. I looked at text and points and taking the polygon symbol that I'd used previously with the black outline red fill, and then substituting it into first a text and then a point symbol through its vector marker graphic. So let's take a look at the text first. So I'll click my place text tool. I'll just add some text. So we have demo symbol type text. I'm going to make a default text symbol. Here's that method that makes the polygon symbol. Okay. And I'm just going to take whatever, and I'm just going to replace whatever's currently in the text symbol .symbol property with my custom polygon symbol. And then there's my resulting text, right? Black outline, red fill. Let's take a look then at the point. So for the point scenario, in this particular case, once again, I took my polygon symbol. I took a default point symbol, set its size to 40. And then from the vector marker, its symbol layer, the vector marker symbol layer, I got its marker graphics and then swizzled its polygon symbol with my newly made polygon symbol here. Okay. And now I get my marker with the black outline and red fill. I just want to digress for a second before we go back to the slides. Talk a little bit about a recipe or an approach, if you will, that you can use for figuring out how to make or construct particular symbols. This is the way I did it anyway when I was coming up with the example code. So in this particular case, we're dealing with graphics. So if I go to the graphics tab, here you'll notice there is on the graphics tab, symbol or text symbol. And what that does is if I kind of select this little format symbol expander button, it brings up the element doc pane, and then it shows the symbol that's being applied currently to the graphic. So in the UI, well, it's kind of nice. I can, sort of select the layers, and then I can just kind of fiddle here to see what things do in the UI. Then if I apply it, I can see the change. And if I want to know what that change is, you'll notice that I have this other tab here called the CIM viewer. The CIM viewer is a download. You can get it from GitHub. I show its use in understanding the CIM, which was an earlier CIM session I gave a couple of years ago. The CIM viewer comes with three things: the CIM viewer itself, something to look at annotation, and then this guy here called preview symbol. And if you click on the show CIM preview symbol, you get this doc pane, which I have open right here. So when I select the symbol with this select button, it shows me the internal structure of the symbol. And in this particular case, you can see that it is a vector marker that contains a symbol layers array. And within that symbol layers array, here's the array of marker graphics, the marker graphics itself. And then here's the outline. So for example, if I want to change the color to red, I can preview that change and apply it. So it allows you to sort of interactively fiddle with the internals of the symbol. And if you're not sure what particular thing does which, you can go back to the UI, maybe add a new symbol layer, change an effect, apply it to the graphic, select it, and so on and so forth, a bit of back and forth. You have to experiment, and it's kind of an iterative process to get it right. So anyway, that is the CIM viewer and CIM preview symbol. Okay, let's talk about geometric effects. So geometric effects can be used to enhance or modify the rendering of symbol layers. They all derive from CIM geometric effect. You apply them directly to the symbol layer via its CIM geometric effect array effects property. Whatever effects are present in the effects array, they are processed in order, one after the other. The output of one becoming the input of the next, and so on, chaining all the outputs together to get the final effect. You can also apply effects globally to the entire symbol, not just to individual symbol layers, but I don't really discuss that in the session. The end result is the same. It's just that whatever the effect is, it is applied equally to all symbol layers in the symbol if it's a global effect. There are a large number of effects. Specifically, I'll look at two of the most common: CIM geometric effect dashes, CIM geometric effect offset. I also have in the example code the use of CIM geometric effect move. Within the Pro documentation for the application, you actually find some really good descriptions of the different effects. Even though the descriptions don't mention the underlying specific CIM geometric effect classes that are used for each of the effects, it's a pretty straightforward process to match the description with the underlying CIM geometric effect class that you would use for that effect. But they all work in a similar fashion, and I'll be focusing on the two in yellow, and of course I have the example for the CIM geometric effect move, that blue highlight. Okay, so CIM geometric effect dashes. You use a CIM geometric effect dashes to apply a dash or a dot or a dash dot, whatever effect, to a stroke. This dash or dot dash effect is built into a number of the symbol factory overloads for line symbol or stroke via the simple line style enum. Values like dash or dot, dash dot, dash dot dot. They give you a ready-made symbol layer or line symbol with a symbol layer that contains a built-in CIM geometric effect dashes. The CIM geometric effect dashes contains a dash template property that contains an array of doubles, and you use that array to control the resulting dash or dot patterns. Values in the array must be specified in pairs. So it always has to be a minimum of 2 values. You use the first value to specify the dash length, and then the second value to specify the dash space. So for a dash pattern or a dot pattern, you need 1 pair. 1 for the dash or dot, 1 for the dash or dot space. Dash dot pattern, for example, that will be 2 pairs. 1 pair for the dash and the dash space, 1 pair for the dot and the dot space. Dash dot dot would be 3 pairs. The dash, dash space, dot, dot space, and the second dot, dot space, and so on. You can influence the pattern by applying different line dash ending values. For example, half pattern, half gap, full pattern, and so forth. And that really applies, sort of an offset. You can begin instead with a full dash with a half dash, or instead of a full gap, you can begin with a half gap, and so on and so forth. There's also an offset along line property that you can use to move the pattern forwards and backwards along the line. As denoted by the asterisk, you can actually also use the dash template to offset the pattern. I'll show you an example of that. Okay, so here are some examples. I have a dash effect instance, my CIM geometric effect dashes. Into its dash template property, I am assigning a series of different double values. In the first example, my pair has a dash length of 4 and a dash space of 4. So here's my dash, and then the space, and then the pattern repeats. So regular dash pattern. In the next example, I have 2 pairs. 1 pair for the dash and dash space, 1 pair for the dot and dot space, and so my pattern looks like this. And then again, it repeats. Now, the values in the array don't have to be the same. They just so happen to be the same in these particular examples. But I can have a dash with a dot space, or a dot with a dash space, whatever. It really doesn't matter. Here's 3 pairs. I want to go a dash, dash space, dot, dot space, and then I want another dot and a dot space, and then once again I repeat. So there's no limit to the number of pairs you want to string together to make your pattern. This last example, this is interesting. I've got two pairs, 0, 4 and 4, 0. Let's look at the first pattern. So I'm saying give me a dash of length 0, effectively meaning that there's no dash, and then I want a dash space of 4. The next pair says give me a dash of 4 and a space of 0, so there's no space. And then the pattern repeats. I get a dash of length 0, a space of 4, a dash of 4, a space of 0, a dash of 0, excuse me, and so on and so forth. The net effect is that the dash pattern is offset by 1. So rather than beginning with the dash, like we see here with the 4, 4 pattern, I begin with the space. So using the dash template in this way is an effective way to sort of offset the pattern. CIM geometric effect offset. You use that with strokes. The offset is stored in an offset property. And then whatever is the offset, it's applied perpendicular to the orientation of the stroke. If you apply a stroke with the CIM geometric effect offset to a line symbol, the result will be a vertical offset, will be a left to right offset if the line is vertical, up and down offset if the line is horizontal, and then of course anything in between, depending on the angle of the line. If you're using the stroke in a polygon symbol, the net effect is that the outline that's using the stroke, well, it'll expand if it's a positive value or contract if it's a negative value. And I'll show you what that looks like shortly. And again, you can customize the effect, the offset effect, via its method property using a geometric effect offset method. And that just impacts the way that corners or sharp bends in the line are rendered. Okay. So here we have a CIM geometric effect offset. And in the first example, I have a line symbol, a line I should say, that I've depicted with this sort of fainter red line, the arrow showing its direction. So it's from to direction, it's from left to right. I apply a positive offset, and that offsets the line to the left, in this case 5 points. In the next example, I have this polygon symbol here, blue fill, red outline. I'm going to apply to it a CIM geometric effect offset of +3. I'm going to set the offset effect method to be rounded. The net effect is the border of the polygon symbol that uses the stroke is expanded. You see this white gap around the actual polygon, its fill. Conversely, if I apply a negative offset, well then the boundary shrinks. Now drawn within the fill. And again, I've kept the same method, rounded, so the corners are rounded. So that's CIM geometric effect offset. So let's look at a slightly more complicated line symbol. Let's use our knowledge of symbol layers thus far, along with CIM geometric effects, to reproduce this, what I'm going to call checkerboard pattern that we see here. Okay, so the first thing we're going to need are some symbol layers, obviously. And we're going to need 4. We're going to need a thick black solid stroke. That's going to be the base of our symbol. We'll overpost on that a slightly thinner white stroke that'll act as the background for our checkerboard. And then we're going to use 2 slightly narrower CIM solid strokes, the combined width of those 2 black solid strokes equaling the width of the white stroke. And we'll use those 2 black solid strokes for our checkerboard. and I'm showing them in Z order. So when we combine them, the net result is as follows. We get a black outline from the thicker black underlying line drawn at the bottom in array position 3, then the white casement in array 2, and then the two thinner black lines at 1 and 0. Okay, so in no particular order then, we need to apply, looks like an offset to reposition the black lines and add a dash effect to get our checkerboard. So we'll do the offset first. We'll use a CIM geometric effect offset. We'll apply it to layer 0 and layer 1. Doesn't matter which, but we'll apply a negative offset, let's just say to layer 1 to move it down, and a positive offset to layer 0 to move it up. The offset we'll apply will be equal to half their width. Next, we need to apply a CIM geometric effect dashes to get our dash effect. And we'll use a dash template of 4, 4, a dash length of 4, and a space of 4. We will apply it to both layers. So currently, we have all of our layers in place. They've been offset, and we have the dash effect. But we need to offset. We need to offset that bottom layer to get the final checkerboard effect. So to get the offset, I could use one of those line ending values like full gap. I could use offset along line, but if you remember, I showed you that technique whereby we can use the dash template to get our offset dash pattern. And so that's what I'm going to use here. To Sim Solid Stroke 1, I'm going to apply a dash template of 0, 4, 4, 0. So 0 being the length of the first dash, 4 being the length of the first space. So no dash, a space of 4, and then a dash of 4, a space of 0. And that will give me the offset of the dash like so. And so there is my final checkerboard pattern. So back to Pro and on with example 2. So example 2, I've broken out into 3 sort of progressions, a step 1, a step 2, and a step 3. And of course, it's to do with our checkerboard line. So let's take a look at step 1. And of course, we're going to be placing a line. I'll digitize my line. And into the demo code then. So now we're on to example 2, geometric effects, step 1. And the first thing that we're interested in is, let's hit continue, making our series of underlying checkerboard layers. And then we're going to place them in the symbol layers property associated with a brand new CIM line symbol. So let's take a look at this checkerboard's layers code here. So there is our black base, that's the thick black line, slightly thinner solid stroke white line that's going to act as the background to the checkers. I'm going to get rid of this breakpoint, we don't need it anymore. Yeah, I'm doing a little customization of the cap style. So rather than it being sort of rounded, I'm squaring it off. And then here are my 2 black strokes that ultimately we're going to apply the dash effect to. Both a width of 4. So combined, they equal the width of this white stroke. And here is my symbol layers array. The 2 checkered layers, they're going to go first, 0 and 1. The thickest layer, it's at the end of the array, so it draws first on the bottom. And then this is the white layer, giving us the checkerboard background. So there is our symbol as it currently stands, right, without any geometric effects applied. And the first thing we need to do is kind of get the offset in place for the two checkered layers in the middle, and then apply our initial geometric effect dashes at the start of our checkerboard pattern. So we'll see that in step 2. So let's go ahead and do example 2. Step 2, I'll digitize another line. Okay, let's go into our example 2, geometric effects. All right, I'll hit continue. So we're back in our example 2, geometric effects. In this case, we're looking at step 2. Get my checkerboard layers, same as before. Okay, my checkers 1, checkers 2, the white background, the black base. Don't think we really need to see this code anymore. I'll remove that breakpoint. I'm going to pull the layers out from the returned array, the checkers 1 and checkers 2. And the first thing I need to do is apply an offset. I need to move one up and then the other one down. So the one that goes up, that will be a positive offset. The one that goes down, that will be a negative offset. And the offset is going to be the width of the checkered layer divided by 2. So I'm going to offset both half their respective widths. Okay. Here's my first offset. Here's my second offset. Notice that one is positive and then one is negative. And then mitered is really actually just the default move method. Okay, so those are my two geometric effects for the offset up and down respectively. I haven't applied them to either of the symbol layers yet. I've simply instantiated them. Here is my CIM geometric effect dashes to create our checkered pattern. They're both the same, dash effect 1, dash effect 2, and I'm going to make the dash be equal to whatever is the width of the line. The net result being that the dash effect will be square. It'll be square as opposed to rectangular. And again, the width of the checker and the width of the space, or excuse me, the width of the dash and the width of the space in the pair, they don't have to be the same, even though they are in my case. Okay, as I know that both lines are the same width, I'm just simply using the checker 1 width here for my second geometric effect dash. Okay, so I have two effects constructed. I apply them, doesn't really matter what order with regards to the effects, into each respective symbol layer's CIM geometric effect array. This guy right here. So here we go. I apply the offset effect, dash effect, into checker 1 effects, and then ditto into checker 2 effects. And there's my line symbol, right? 4 layers. Okay. And there is our result. We've got the checkered pattern, right? You can see that we've kind of gone from this to this. The black layers on top, they've been offset up and down respectively. And then the CIM geometric dash effect has been applied, but there's no offset there, right? So we still need to offset that bottom symbol layer there. Okay, let's see how to do that. So I'll go to step 3. Once again, I'm going to digitize my line, A line. Okay, and we'll step back into our example 2, geometric effects function. Just hit continue. Okay, so now we are on this third progression, step 3. I'm just simply going to call myself recursively, example 2, geometric effects. So I now need to take the end product from step 2. I'm going to take the stroke at index position 0. I'm going to get its checkered effect. That's the CIM geometric effect dashes from its effects array. Now the dash template as currently is what? It's 4, 4, right? So it's got a pair of values, 4 for the dash, 4 for the space. But what I want to use is I want to use this offset, right? So I'm going 0 for the first dash, 4 for the first space, and then a second pair with a width of 4 for the dash, and then 0 for the space. So I'm using the dash pattern to apply that offset. And of course, there's other ways I could go about doing it. This is just the way that I chose. And then I'm just applying it back into the effects array, and then back into the effects property itself. And then last but not least, I assign now my modified sim solid stroke back into the line symbols symbol layer collection. And there is my completed symbol right there. Okay. Let's look at hatch fills. So hatch fills, they're not actually a geometric effect. They're actually a symbol layer. The sim hatch fill symbol layer, it contains one of those nested symbols I mentioned before, a line symbol that you can use to customize the symbology of the hatch, and it can be any line symbol you choose. Hatch fill has two properties for spacing and angling the hatch, simhatchfill.separation and simhatchfill.rotation. The rotation is in degrees, and positive degrees are measured counterclockwise from 0 degrees being horizontal. If you want a cross-hatching effect, simply stack multiple sim hatch fill layers. So to make the hatch or cross-hatch patterns, we actually have some built-in symbol factory overloads that you can use using that simple fill style enum. Get various different crosshatch patterns kind of ready to go, if you will. You can also roll your own using the construct hatch fill overload on symbol factory. Just provide the color, the angle, and separation you want to use directly. Or you can just instantiate one from scratch, as I'm showing in that code snippet below. So here I'm just making a hatch fill, new sim hatch fill. I'm applying a rotation of positive 45 degrees, a separation of 5 points between the hatch lines, and then I'm just providing a line symbol that I'm pulling from the symbol factory, whatever that one is that I've chosen. So here's some examples. Let's say that we're using the construct polygon overload for the symbol factory or the construct hatch fill. Doesn't really matter. I show the simple fill style with the underlying rotation and separation values along with the effect. So if I specify a simple fill style of 4 diagonal, that's essentially equivalent to rotation of 45 degrees, slope of 1, separation of 5. Backward diagonal, well, that's simply the 4 diagonal, but just reversed. So a minus 45 degrees, slope of -1, separation of 5. Simfill style diagonal cross, well, I'm just stacking a 4 diagonal and a backward diagonal layer. Simple fill style cross, got a vertical line, rotation 90, horizontal line, rotation 0, same separation. Give me the cross effect. And then here, for example, I'm combining the cross pattern with the 4 diagonal pattern, 4 layers. Rotation 90 and 0, that's from the cross. 45 and negative 45, that's my forward and backward diagonal respectively, giving me that pattern right there. So no limit to the stacking combinations or whatnot of the hatch fills. All right, let's talk about markers, sim marker, and specifically we're going to look at sim vector marker and sim character marker. Generally speaking, they both consist of an anchor point. They also have an angle and offset for the marker or the character glyph. Vector marker contains a shape. Character marker contains a glyph identified by a character index and a font. You can also have, as we'll see, a marker placement associated with the marker. It's optional, and you can use it to influence its placement, the marker's placement, when used in conjunction with strokes and fills. For example, if you want to place a marker on the ends of a line, use it with fills inside a polygon as a stipple, and so forth. A little bit more detail then. Sim vector marker, it contains one or more sim marker graphics in a marker graphics array. Typically, there's only one, but you can have many. Each marker graphic contains the shape of the marker, and the polygon symbol to render it. The shape can be a predefined shape, circle, triangle, diamond, square, whatever, but it can also be completely custom. And the polygon symbol can be any polygon symbol. Character marker, instead of a shape, it actually has a character index, the font that character index comes from, along with the style, regular, bold, and so forth. And then that character glyph is essentially the equivalent of the sim vector marker's marker shape. And again, it has a polygon symbol that it uses to render the character glyph. There are a variety of different symbol factory overloads that you can use. So in the first three, I'm making three different types of vector marker, each with a different shape, a predefined shape identified by this simple marker style enum. In this case, diamond, circle, and square, in varying sizes and varying colors. The first one is red, the second one is white, and then the third one is blue. In the next example, I'm actually providing the fill and stroke that I want to be used for the underlying vector marker polygon symbol to render the marker graphic shape. Notice also that the marker graphic shape, I'm not using a predefined shape in this case, I'm providing my own. It's just a custom shape contained in this shape called custom poly. In the last two examples, I'm making a character marker. The first one, I'm using the character index 123 to be found in the font called Windings. I want its style to be bold and its size to be 12. In the second example, I want character index 70 from the style Esri default marker. Give it a font style of regular, a size of 12, and then I want the color of its internal polygon symbol to be blue. All right, so as I did mention, all sim markers contain a marker placement property. You can use the marker placement to place the marker at the ends of lines, inside polygons, along a line, around a polygon, and so on and so forth. So unlike sim geometric effects, markers only have one placement, not an array. And you simply assign it into the marker placement property. There are no symbol factory overloads available to create predefined marker placements. So you have to roll your own from scratch. Okay, so marker placements, they all derive from one of two classes. If the marker placement is being used on a line, they derive from sim marker stroke placement. If the marker placement is being used to influence a marker's use with a fill, a polygon, it's sim marker fill placement. And of course, sim marker stroke and sim marker fill placement both derive from the parent class sim marker placement. Specifically, we will look at marker placement online and sim marker placement at extremities. Those are two of the most useful. I do have in the code example a use of sim marker placement inside polygon to show you how to customize a stipple fill. So let's look at sim marker placement at extremities first. It contains an extremity placement property that you can use to control the marker placement at line ends. Whether you want the marker placed at both ends, just the beginning, just the end, or none of the above. Marker placement at extremities also contains an angle to line property. Set it to true or false as to whether you want the marker angled to the line or not. It also has an offset along line that you can use to move the marker forwards or backwards from its initial position along the line. So the code snippet below, I'm instantiating a CIM marker placement at extremities. I'm setting the extremity placement to be both. So whatever my marker is, I want it placed at both ends of the line, and I want it angled to the line as well. And here's my assignment statement here below. Marker placement on line then, it contains a relative to property that controls the marker placement on the line. For example, on the line middle, the line beginning, line end, segment midpoint, and so on and so forth. It too has the inherited angle to line property, set to true or false, and a start point offset. So wherever the marker is located on the line, you can move it forwards or backwards from whatever is in that specified location. The code example, I'm showing instantiating a CIM marker placement on line. In this particular case, I want my marker placed at the line middle, and I want it angled to line. Okay, so let's look at an example to put our newfound skills with markers and marker placements into practice. Let's say that we want to construct this custom dimensioning style that I show here. So we're going to base it off of a CIM solid stroke, so no surprise there. We're going to need some kind of marker to act as the arrowheads that we show at the ends of the line. One approach we could use is we could use a vector marker. We could use the marker style triangle, solid fill black, and then give it a rotation of minus 90 degrees. But options, there's lots of options in the CIM, as I think you're seeing. Instead, I think I'm going to use a character marker. There's a special font for just this purpose called Esri Arrowhead, and I'm going to use the character index 63. Gives me a ready-made arrowhead like so. I'm going to use another character, the minus sign actually, index 95 from the Arial font, as my little vertical hash or tick mark, and I'll give it a rotation of 90 degrees to make it vertical. The next thing I need to do is I need to move those markers to the line ends. Well, we've seen how to do that. I'm going to use a marker placement at extremities. And I'll apply that to the character marker for the arrowhead, and I'm going to set extremity placement to be extremity placement both. I'll apply the same marker placement to my vertical hash mark. And so at this juncture, my line symbol kind of looks like this. I've got the solid stroke at the base, and then two character markers, each with the same marker placement to place them at the line ends. Now the arrowhead isn't quite what I want visually. It's placed at the anchor point. The anchor point of the marker is actually what's on the line end. What I want is the tip, the arrowhead tip. There are various ways to offset the marker. One of them, of course, is that offset along line property. But there is another offset that you can use. Thing with CIM, lots of options. There is actually an offset on the anchor point itself. So that's what I'm going to use. And I'm going to set the offset to be relative, a relative offset of 50% or 0.5. I still need that middle hash. So I'm going to use another character marker, same index 95, Arial, rotated 90. To get it in the middle of the line, I'm going to use the marker placement on line, and I'm going to set its relative to property to be line middle. And so there's my completed dimensioning symbol there. 4 layers, 3 of them characters, 3 different marker placements, 2 using the placement at extremities, extremity placement both, one of them using the placement online. Okay, so we are on to example 4, our dimension line style. Here we go, step 1, and we're dealing with line, place line tool. Okay. All right, our breakpoint, we're back in the module class, our get symbol for example. Our example is currently set to be example 4, dimension symbol, step 1. All right, so in this particular example, we are going to make the corresponding CIM symbol layers required to make that dimension line style. And I have it encapsulated within this method here, dimension style layers, from which we're going to return an array of CIM symbol layers. Okay, so here we go. As discussed in the slides, we know we need a solid black stroke. That's kind of the basis for this whole thing. That's what I have here. And then a couple of character markers, right? The arrowhead, character index 63 from the font Esri arrowhead, the style regular. I'm using that particular construct marker overload on the symbol factory. And then for the dash, we're going to use the minus sign, character 95 from the Arial font style regular. And I need to rotate it positive 90 degrees to flip it vertical. Okay, so those are currently my 3 symbol layers: the stroke, the arrowhead, and the dash. Okay, now we want to place both the arrowhead and the dash at the end of the line. So I need a CIM marker placement at extremities. My placement is going to be both. The angle of the line is true. The place per part, that's just whether I want arrowheads on every single part or just on the ends of the beginning and final part if there happen to be more than one. I assign the marker placement into the arrow.marker placement equals the end marker placement, ditto for the dash. And I add them to my symbol layers array. Okay, so the end dash, it'll be in 0, the arrow at 1, the stroke at 2. So the stroke will draw first, then the arrow, then the dash. Okay. And if this is step 1, I'm done. I'm just going to return. And here I'm making my line symbol. I'm adding in that CIM symbol layer array. And I don't need these breakpoints anymore, at least not now. Okay, so there is our dimensioning symbol as it currently stands, right? There's our solid stroke, the arrowhead, a little bit difficult to see, I'm sure on the video, but we can see the arrowhead and our dash, our dash. In fact, if I select it with the CIM viewer, we can see the preview there, and we notice that that dash line is on the end, but the arrowhead, it kind of sticks over at the end of the line. And so the next thing we need to do, of course, is to move that arrowhead back. Okay, that's what I'm going to do next. So that is our step 2. I'll digitize another line. Oops. Need my place line tool. All right, so here we go. Example 4, dimension line symbol. Back into our dimension style. Layers, private method. I make the same series of layers. So I'm going to take it all the way through step 1. I'm not going to repeat that code. And then we come to step 2. Step 2 down here. So I'm taking the arrow, CIM symbol layer, that's our character marker with the arrowhead, and I am applying that offset to the anchor point. So my anchor point units are set to relative, so this is a relative offset, and I'm offsetting it in the X direction by 0.5 or 50%. And that should give me the arrowhead exactly on the end, and there we have it right there. I'll just select it again to put it in the CIM viewer. And there we can see now in that preview, hopefully you can see that on the video, the tip of the arrow is now at the line end. It's now at the line end with that little anchor point offset. Okay, the last thing we need to do is I need to place that middle hash, and that I have in step 3. Back to line, digitize a line. Okay, one more time. Example 4, dimension line symbol, let's call it. Okay, so we're going to do all of step 1, which is essentially make my stroke arrow, dash, the marker placement at the ends. Step 2, the offset to get the arrowhead tip exactly on the end of the line. And then we'll come here into step 3, and I am making another marker. Okay, the clone method, that's a custom method. I explain it in Understanding the CIM in that session. Essentially, I'm just using it to make a copy of the end dash, right? That Arial font character 93, the minus rotated. And I'm going to give it a marker placement on line. Marker placement on line. Place per part true, so actually in this case I'm going to put that middle hash on every single part. If there's more than one, angle the line true, and then I want it placed at placement on line relative to line middle. And I add the marker placement to the middle dash marker placement property, and I am inserting it into the beginning of the symbol layers array. Why? Well, because I want this to draw last, or at least I wanted it to draw after the stroke and not before. And that is our step 3. So there is our dimension line symbol, at least as we currently know it, with the little middle hash now added, arrows and dashes at the ends, and the arrow tip correctly positioned at the end of the line. So a dimensioning style, well, it's not much good really, is it, without some text showing the line length. So how are we going to do that? Well, if you recall, vector markers contain a marker graphic. Actually, they can contain multiple marker graphics in an array of marker graphics, but typically they just have one. And within the marker graphic are 2 components, a shape, it's typically a polygon describing the shape of the marker, and then a polygon symbol. Well, as it turns out, we can replace that shape and symbol with a point instead of a polygon and a text symbol instead of a polygon symbol if we want to use the vector marker for text. The marker graphic has a built-in text string property. Then that text string, whatever it is then used, as or shown, shall we say, as the text string label. The code looks like this. I'm instantiating the marker graphic, so this is the marker graphic that I'm going to be using, and I'm specifying a point for its geometry. So map point builder, create map point 0, 0, and that'll be the insertion point of the text. I'm just using the default text symbol, whatever that is. And then whatever is the literal string that I assign into text string, it's the text string that will be shown. I need a vector marker. It doesn't matter what vector marker. I'm just teeing up whatever is the default vector marker. And then I'm swapping out its marker graphics with its polygon shape and polygon symbol with my marker graphic with the point geometry and text symbol. And so that's how I do it there. All right, so back to our dimensioning line style then. We need to add in one more layer, a CIM vector marker layer. We need to take its polygon symbol within the marker graphics and swizzle it with a text symbol. The marker geometry, we need to change from polygon to point, and then we need to set the marker text string, in this case to the length of the line. To get the text to the middle, we will use a marker placement on line. Placement on line relative to dot line middle. So it's not quite right. The text is directly over the line, but we actually want it offset. We want it offset and kind of centered above that middle hash. So again, number of ways to do this. I'm actually just going to use the text symbol offset. It has 3 offsets for X, Y, and Z. So lots of options with the CIM. I'm going to set an offset Y of 10, offset X of -10, and that will position the text in our final position like so. Okay, so we are back to example 4. And on the final step, step 4, our line tool, and let's digitize our line. Okay, back in the module class, get symbol for example. Our example is currently example 4, step 4. And once again, we're going to make our dimension line style. You may have noticed in the previous demo that I was calling this method example 4 dimension line symbol with a text parameter. And I was ignoring it in steps 1 through 3. But this is the text that we're going to be using to annotate the line. And it actually represents the length of the graphic that's going to be annotated. So let's just take a quick look at that code here. We really haven't looked at the implementation of those place, point, line, poly text tools. I mean, they're really not that important for the purposes of the demos. So this is my place line tool implementation. The geometry is a polyline. And if I'm on step 4, in example 4, I actually take the length of the line. I'm doing a little bit of cleanup here to just truncate the string to 1 digit of precision. So there's my length. And then I call this get symbol, for example, overload with the length string. So that's all right. So I'm into my dimension style layers method once again. So we're going to do everything that we did in step 1 plus everything we did in step 2 plus everything that we did in step 3, right? This progression. I'm not going to go through that code again. And then we're going to come to step 4. So at this point in time, we've got a stroke, the arrowhead's on the end, the hash is on the end, the hash in the middle. Now what I need to do is I need to add a marker to our symbol layer collection that we can use to display the text. So remember, the way I do that is I take a vector marker and I swizzle out its polygon for a text symbol, polygon symbol for a text symbol, and its polygon shape for a point. So I make my vector marker. It doesn't matter what vector marker I use. It's totally arbitrary. I'm going to swizzle out its marker graphics anyway, setting the size to 10. And here we go. I'm going to make my text symbol. I'm just going to use the default Arial font size 10. I'm going to make my marker graphic. So this is the guy that's going to contain my text symbol. So here we go. The geometry, that's going to be the point. That's the placement point for the text. The marker graphic symbol is going to be my text symbol. And the text string will be the line length. Okay, here is the marker graphics array of my vector marker. I assign into it my newly made marker graphic. So I'm going to replace the existing marker graphic with my marker graphic containing a point and text symbol. Done. Still need to place it at the middle. So I make another marker placement on line relative to line middle. Placement per part is false, angle to line is true. And I assign my marker placement to the vector marker placement property. The last thing I need to do is just clean up the text position. So I'm applying an X and Y offset just to move it up and slightly to the left. And then I'm inserting my vector marker into the symbol layers mix, and I'm putting it right at the front. So my text is going to draw last. And there we have it. So there is my dimension line symbol. the text length now positioned over the middle, right where the middle hash is located. Okay, so as I alluded to at the beginning of the session, there's just some material, some of the examples that I couldn't fit into the session just because I was out of time. One of the extras I included in the demo code, which really it's outside the scope of the session, is how to use that dimension line style with a feature layer. So I do have in the contents, I have a line feature class called demo line features, and that's why it's there, to show that custom dimensioning line style. So essentially you just push the modify renderer button. What does that do? Well, you can step through the code, but you'll see in code that it modifies the renderer, applies the dimension line style to the renderer, and then also adds something called a primitive override. And then the place line feature tool, that's actually constructing features in that feature class, and of course each feature is annotated with its length. So there were a couple of other examples as well. The first of those is kind of a sequence on the different crosshatches, crosshatch 1, 2, 3, and 4. So that'll work with the place polygon tool. You just select one, digitize a polygon. Shows different cross-hatching examples, and you can step through the code to see how that's done, but it pretty much matches up with what I did describe on the slide. I also have use of marker placement inside polygons shows stipple fill. Okay, so two types, fixed and random. So here's a polygon, right? And I'm just taking a generic circle marker symbol and using it to make a stipple fill. So you can see that in the code too. That's example 5 with a fixed and a random pattern. And then the last example is CIM geometric effect move. Show a drop shadow. Okay, so drop shadow on a point, align, polygon, and then text. Okay, so that's drop shadow using CIM geometric effect move. So all of those are included in the downloadable code, but yeah, just really no time to run through them. So let's conclude back at the slides. Okay, well that finally concludes our session. If you made it this far, I certainly appreciate you sticking with it. It's a long session, and we certainly blew through the time constraints, the typical time constraints for a session. We covered quite a lot of ground. We looked at the main structural components of CIM symbols, layers, how to manipulate layers with geometric effects, how to digress slightly with Hatchfields. We looked at a variety of different combinations of symbol layers, and hopefully some useful examples to kind of illustrate the various techniques of manipulating the CIM symbol internals. And as I mentioned previously, there are additional examples that just had to be excluded. They couldn't make the time cut. But I've left them in the demo code, and I've also left in the slides. You'll find in the slides, if you want to download them, the workflow for extracting symbols from a style project item. And you'll find all of the session content at this link on the ArcGIS Pro SDK repo, public repo in GitHub. That concludes the session, and thank you.